Okay, for systems of second degree equations, you guys are always asking me to validate why we do this. So let's say there was an earthquake in California. Now, understand that I'm an oil and gas guy, and fracking is good. Okay, but Oklahoma, for instance, has seen an exponential increase in earthquakes since they started fracking. Okay, you put water into slip surfaces, guess what? It's a lubricant. More is going to happen, right? So this might become an issue here. I don't know if it will, but just a heads up there. In Oklahoma, it's really a big issue right now. But if you have an earthquake, we have seismic stations all over the place. Okay, those seismic stations will pick up that earthquake and record the time that it hit that station. Okay, based on that time, we can calculate how far away from the earthquake epicenter each station was. Okay, if we have 3 stations, we can actually figure out where the epicenter is, because those distances form circles. Okay, these are the possible spots for the earthquake based on that station's data. And then you'd have this one. Right, you have data from that. So there's 2 possible locations. And then you'd have a third location, which would give you, this is going to be a big circle, but the intersection of all 3 circles is the epicenter of that earthquake. So this is kind of one use of systems if you're going to be a geologist and into that stuff. But hopefully it doesn't become an issue for us. Scary. I've been through lots of earthquakes, some scarier than others. It's really not that bad in a building like this. Yeah, that's probably not going to happen. Okay. So, I've never felt an earthquake here. Anybody? Never? We had someone as a kid in Moab. Alaska is where it's at when you want earthquakes. They have about 50 or 60 a day.
My grandma felt it when they were testing like nuclear stuff and like realism or something. Yeah. She felt the stake in the ground all the way in there.
Just in case you're curious, here's the earthquake map for the United States right now, current. This is, say, guess where that is? That's Oklahoma. I was just telling you about that, right? The bigger, so here's earthquake age. Okay, the red one happened within the last hour, and the orange within the last day. California, guess what that is? That's the San Andreas Fault. You go up to the plates, and there's Alaska. And then if you click on it, it tells you the data, like exact location and time, and it gives you a magnitude 4.6. So the bigger the dot, the bigger the earthquake. Anchorage is right there, so this is about 150 miles from Anchorage. That was a 2.8. They may not have felt it. I mean, 3.2 maybe. So you can see that, like here's the Alaskan Peninsula. There are Kodiak Island, lots of earthquakes in this area because of this subduction of this tectonic plate. Okay, so just to satisfy your curiosity there, if you had any, anyways. It can. The whole world? That's a good question. Let me get it back up here. And keep in mind, this only shows 2.5 or bigger. Earthquakes, 2.5 or bigger. There's the world. Hey, notice where they all are. Tectonic plate zones and Oklahoma. Yeah. Okay. This is the Ring of Fire, the Pacific Ring of Fire. Yeah. Oh. Lots. What's that one? Okay, that was a 5.0. And look at that spot. That's a hot spot right now in the Philippines. But yeah, it's got its pluses and minuses. The weather's a little bit more warm in these areas. Anyways, there you go. So we're going to work here mainly with your conic sections and lines. Okay, so we can have a solution with no intersections, right? So we can call that no solutions. Here's a sample of one solution, an ellipse and a, I guess that would be another ellipse, not a circle. Shut up. I'm gonna, never mind, you don't want to know.
I'm pretty sure people on the camera.
Two solutions. Can you draw a picture for two solutions? Go ahead. With just two items. We're only going to worry about two. Yeah, that would work. A Venn diagram. 1, 2. Can you think of a 3 solution? Yeah, 3 circles. Can you do it with 2 shapes? Because that's really what we're going to focus on.
If they were misshapen.
Caleb says parabola circle. Bam.
What about an ellipse in a circle? The ellipse is vertical.
How many is that?
4.
Yeah. Ellipse and circle. Can you have 5? Just 2 shapes. Just 2 shapes. If we included polynomials, we could certainly have 5, but a what? Yeah, if we were including those, we could. Yes, but we're not including them today. We don't want to get into that. It's ugly. No, it's not ugly. It's beautiful. But this is the lies. Lies. So 4 is where we stop unless it's infinite. Infinite would be the same shape. Okay. So let's solve a system both algebraically and graphically.
Oh, you can do it. That was a square.
Can anybody identify that shape? No. It is a hyperbola. Okay, you're used to saying equals 1, correct? Yeah, so we would have to,
If you want to fix it to equal 1, you divide by 20. So we would get x squared over 4 minus y squared over 5 equals 1. Okay, we'll use that to graph it. Okay. Then this one. What's that shape? It is an ellipse, yes. We can, again, divide by 64, and you get the form you're used to. I believe this is 16 and 1. Okay. Keep in mind, a circle only has x squared and y squared. No numbers multiplied by the front of it.
Wait, so the bottom of the circle?
It's an ellipse because it has 4x squared.
Oh.
The circle would just be x squared. So hyperbola and ellipse. You graph them or solve it algebraically first? Oh, okay. Remember our method substitution and elimination. Which would you prefer? I would prefer elimination myself. How can I get the y squareds to match up? Yeah, let's multiply this one by 4. So it's the same method we're used to. And then leave that one the same. Add or subtract? Yep. Six. Is x squared equal to 6?
Yeah.
And x equals positive or negative root 6. Nice. 144 divided by 24. Okay. And then square root it to get your x value. All right. What do I do with that number? Plug it back in. Um, 30. Four y squared equals negative 10. Am I going too fast?
Yeah.
A little.
Okay. Can you see it? Is that better? Do I need to worry about putting negative root 6 in? I put positive root 6 in. Do I need to worry about the negative? Same answer because it's a negative that's squared. Yep. So our answer, you can write it like this. It's a lot easier. Now that mathematically says every combination of the two numbers, or four numbers, really. It makes it more simple.
What happens if there's 3 equations? Oh, will there be 3 equations?
We will not run into that today. Because I could have, 5 months ago, I could have showed you how to solve those. I did not, in favor of moving on. Yeah. Okay, let's graph the both and see if we can. Okay, I'm going to do the hyperbola in red. What is A?
A.
2. B is root 5. And then the asymptote slopes, because it's horizontal. Yep. What's root 5? 2.35? 2.36. So off. Thank you. Center is 0, 0. Well, root 5 is 2.3, right? 2 1/3 basically. So I went up 2 1/3-ish over 2. It doesn't have to be perfect. It's just approximate. And there's our hyperbola. And remember, A is the distance from the center to the vertex. All right. B gives you these numbers up here, how high this box would go. That value is B. That's A. C gives us the focus, and we don't even need it to graph it, so I didn't bother with it. And now our ellipse. Unless you're still writing. I will slow down. Get in a hurry. Oh yeah, I just love it when that happens.
I need a different one. It's matching perfectly with the donation.
You ready to move?
Yeah.
Okay, A is, B is. That's all we need. Centered at 0, 0. It's horizontal. So we go 4 left and 4 right, and then 2 up and 2 down. And we have our intersection points. Looks like if you do the math on these, it looks pretty close. So you got them both. Now, of course, graphical is not an exact answer. If you're in a science field, you want an exact answer if you're doing any of this. Pretty much. But we're just verifying those. Okay. You will run into linear intersections with these. I think you could probably handle those pretty easily. I would use substitution. Do you want me to show you one, or are you good? Or show you on Tuesday? Right. Tuesday. Yeah.
Number 1.